Hi there, and welcome to Timber Engineering and Introduction. Today I will provide an introduction to timber engineering, which is part of the advanced structures at master's level in the MSc, and also to a selection of the MN students who are currently studying on civil engineering. And I'm Professor Robert Hairstands. The learning outcomes of this course will be in order that you understand the material properties of timber, how it's characterised for structural use, understand both serviceability and ultimate limit state, design criteria and principles for structural timber design, including durability, dynamics and performance in fire. Be capable of analysing and designing statistically determined beams, columns and load-bearing elements. Describe the behaviour and load transfer mechanisms in timber structures, and analyse and design structural timber systems, as well as develop creative solutions for open-ended design problems. There's a full schedule in front of us. Please check your timetables if you are attending class with respect to where the room is. But we have a range of individuals that will be delivering over the course of the coming weeks. So this module is normally it's a team taught. I would say in this instance that Bernardino is actually being replaced by Andrew Livingston in terms of week 4 and week 5. But fundamentally all the content will be covered. We'll explore the different varying systems, connections, etc. And we'll also expand upon this through case study analysis. So it's a really, really intense but wide-ranging knowledge that you'll get from this with regards to timber engineering. In terms of assessment, we normally have an exam as part of this, a coursework and exam, but what we're doing now is we're having 2 courseworks at 50% each. The first one is on truss failure in week 8, and then the second one is a series of tailored questions, which will be distributed near the end of the schedule for you to undertake in your own time, but everyone will have questions tailored to them, so everyone will have different answers to provide. We have a recommended reading list with respect to this course. Some really good work out there in terms of how to use Eurocode 5 or the underpinning knowledge and principles to the design approaches, and indeed even the Timber Engineering Step 1 books, which date sometime year back but are actually really useful, and indeed I used them a great deal when I was learning about timber engineering. We don't want just to think about timber engineering, we want to think about also the mechanical properties of wood and wood composites. So Boddick and Jane is a really good book in that respect. We'll give you a good overview. So a lot of good resources out there, not just limited to these textbooks. There's further ones, and these should mainly be available via the library, or of course you can purchase them if you like. And Timber Engineering by Svante Andersen and Hans Larsson is a really good book to explore the different theories that underpin timber engineering. So I would advocate that you look to ascertain one or at least 2 of these books, particularly if you want to move forward with timber engineering your career choice. There's also good research papers out there. There's a plethora of research with respect to timber engineering. This is actually a really good paper I would suggest that you download and get hold of and read, because it will give you a really good summary of timber, the utilisation of timber in the built environment, and indeed the considerations of timber engineering. So it considers, from forest floor all the way through to engineered timber products and all the steps that are in between, and explains the varying products and systems and what influences them, and including things like modified timber products. So it covers trees, molecular structure, forest and silvicultural practices, processing of timber, varying wood treatments, the structural use of timber, fire resistance, durability, what happens to the end of life, and it considers a range of species across the globe. So it provides a nice wide-reaching, of information. So I would encourage you that you read that, because it will help you to understand timber as a resource through the course of this lecture and our course series. As I say, there's a lot of work out there, and indeed I also of course have my own work which I've published, and if you're interested in any of this, then the links that are shown here will take you to this. I would encourage you to look at crane and erection of timber truss rafter roofs, because that will be useful for your coursework. But there's a series of other publications that are available as well, including my most recent publication, or one of my most recent publications, which was the second edition of my book, published via Trada, Offsite and Industrialised Timber Construction. And a lot of the content that populates this course will be extrapolated from that. So a useful textbook indeed. And of course, there's journal papers in the mix here as well, and research papers covering both timber engineering, but also things like collaborative frameworks to encourage the utilisation of timber. A very recent publication, I think it's very timely, that's come out from the structural engineers is Can MMC Help Save the Planet? And timber and natural materials are very much included in this. So I would encourage you to download this publication. I understand it's free to download, and it looks like, the impact of embodied energy and embodied carbon in delivery of the built environment, which is critical, and how these types of approaches need to be scaled. Hence why timber engineering or timber needs to be scaled, because it's a naturally renewable resource. And that's going to become more and more important as buildings become more energy efficient, and actually the embodied energy of the building is more important in terms of its overall energy use during its lifespan. So you can see how that how the pie chart has moved in that regard, and how going forward it's going to become more and more important we use low embodied energy products such as timber. I have my own paper that I collaborate on with other authors that's included in this publication, and it looks at the 5 capitals model for sustainability and how off-site construction can relate to that, with a particular emphasis on biogenic materials, so natural renewable resource, which of course timber is part of. And just to cover off on that, to give you an understanding of some of the theories that we're moving forward with, and why we should be using biogenic off-site manufactured approaches, is because fundamentally for the delivery of the built environment, and in order to have a sustainable future, we have to think very differently about how we achieve this. And there's a theory out there from Forum of the Future around how to best achieve a sustainable future through a system change. And fundamentally, that's what we need, is system change given the climate crisis. So if we think about the 5 capitals model, the 5 capitals model is thinking about, rather than the current sort of capitalist, consumption and productivity, it thinks more holistically about different capitals within the organisation, within the global organisation indeed, or even the organisation of Scotland. So we have to think about manufacturing capital, financial capital, social capital, human capital, and natural capital. So manufacturing capital in terms of what's the products and processes that we're employing, financial capital, how does it impact upon the economy? What does this mean in terms of society and social cohesion? How does that influence the human capital in terms of skills and knowledge exchange within society? And how do we utilise natural capital for the delivery of what we want, and renewable natural capital for that basis, so that natural capital is replenishable, so that we're not undermining it for future generations. Hence why, in terms of the delivery of the built environment, if we think about the utilisation of natural renewable resource, then timber is obviously a key component of that, and actually aligns with the necessity to deliver the built environment in a more environmentally sustainable fashion. So those are some of the theories that are explored within that paper, and I would encourage you to look at that and understand that, and correspondingly get a feel for why timber engineering is actually a very important subject matter going forward. So in line with this, as I say, what we're concerned with in many aspects is the delivery of the built environment, and we've worked on a number of case study projects in this regard, and those you can see in front of you, ranging from domestic dwellings, bespoke one-offs, to the tallest timber building in Scotland, to the rollout of the Commonwealth Games Athletes Village, even the Dyson Institute of Engineering and Technology. And some of these case studies will be explored during the course of the project to get an understanding of some of the work that we've done on the delivery of these. And of course, it's not all just focused on housing and residential. There's infrastructure, and there's other types of or other building typologies, and we'll start to look at those as well. But fundamentally, it's about the built assets, how these built assets can be constructed and delivered for the delivery of the built environment. more and more what we're also seeing is, with respect to this, is the built asset also has a digital asset or a digital twin. So digital twins can capture the information with respect to that built asset, so you understand, uh, you know, the most productive way of delivering it, or what its carbon credentials are, or what's necessary in terms of manufacturing capabilities to deliver that built asset, or indeed the structural properties or the low carbon energy and heating performance of the built asset. So that can all be built into the digital twin in order that you have fully informed design. So it's important to consider that, and again, we'll explore some of this during the course of uh, the program that you're on, but fundamentally, we'll of course focusing on the timber engineering aspects of it. So it's very important that these assets are digitally enabled, and of course, structural engineering is a key component of. So I just wanted, hopefully that gives you a wee bit of context, but what I want to kind of just a wee bit of explanation here in just in terms of who I am, what I do, and why I work, and the research work that I undertake or my team undertake feeds um, into timber engineering. So I run a research centre on offsite construction and innovative structures here at Edinburgh Napier, and we have a strategic objective to research, innovate, and commercialise construction technologies for tomorrow's communities, working in partnership with external stakeholders in the industry. So we lead on fundamental and applied research for industry, government, public sector bodies in the thematic area of industrialised building systems. And just to note, we don't work in isolation, we work in collaboration, and we have another research centre at Edinburgh Napier called the Centre for Wood Science and Technology that understand the properties of wood, what's needed for different uses, ways to improve performance and value through forest management and processes. And indeed, Dan Ridley-Ellis, who leads on the Centre for Wood Science and Technology, will provide a lecture within this course. So that will give you an understanding of the work that they do, how it interfaces with what we do, in order that we can add further value to the timber resource in order to deliver the built environment more sustainably. Just to mention that our work is very much about core research and applied research, working with the industry in order to create impact for the delivery of those sustainable communities. And we do external engagement with industry and the wider stakeholders and partner often with them. But fundamentally, what we also do is underpin this through something called the Built Environment Exchange. And if you're interested in the Built Environment Exchange, then you can certainly look it up and see how you could get actively involved. So what we're constantly doing is encouraging students to engage with industry through our research activities. So just a brief overview of BECS and what we're trying to do through this in order to change construction culture through collaborative research. Is essentially it's a platform approach to accelerate change in culture and develop dynamic talent and deliver experiential learning. So we provide opportunities in terms of internships, postgraduate scholarships, even employability on our projects. And often what we've done is wrap this around with augmented learning and facilitate student mentorship. So as I say, if you want to find out more, please do visit the website. What it also what it does is ideally create a pipeline of talent to affect that cultural change, and within the Built Environment Exchange, that mentorship piece is key, and we encourage students to go back into high schools and help with the delivery of design, engineering, construct, which importantly can be delivered remotely, which is handy given the current climate. And ultimately, what we're trying to do is encourage international awareness, get our students internationally recognised, and develop a global mindset with our students. And why are we doing this? Because we recognise that for the delivery of the future environment, we have to think about efficiency, sustainability, and value. And so it's how we encourage that mindset into future generations in order that we can make a difference essentially. So some of you are doing um, the MSc in Advanced Structures. So if you weren't aware, we have actually postgraduate scholarship available to us, and I would encourage you, if you're interested, to go to the link on this slide to see if there's opportunities that you can tap into to have your masters funded. And often a prerequisite of that is that you help out with the mentorship piece, but you also engage with industry for your research project. In terms of the research centre itself and what we do, we work with the Innovation Centre, we work with industry partners, we create published outputs, and we also underpin the delivery of the built assets with our research, and we also do outreach into the public to encourage the utilisation of timber and off-site construction approaches. So why off-site construction, or indeed what is off-site construction? Well, there's a range of products and systems that go from panelised to volumetric to hybrid to sub-assemblies, and information with respect to those is unpacked further in the publication listed. There's different within those different segments as such, there's a range of enhancement. So you can go from open panel all the way to fully enhanced closed panel systems, including windows and doors and insulation, or fully volumetric, including, if it's a bathroom plot, including sanitary ware, the pipes, the plumbing, or indeed the installation of the external lining and the internal lining and external cladding. Or it could even be, the um, the introduction of renewable options such as solar panels, or heating systems. And we have to think about the serviceability challenges with respect to that, i.e. the movement of the system when it's been lifted into position, because it can affect what's taking place with respect to for example, if renewables are embedded in the system. So you don't want a disconnection essentially to create a leak or a fire hazard or whatever it may be. So we have to think about the range of systems and correspondingly what was necessary for the design challenges of those. With respect to off-site construction and timber off-site construction, it's been around for a long time. Medieval cruck frames were actually manufactured in the carpenter's yard in order to check them before they were then transported to site and erected. We had the Manning cottage, which was circa 1830, which was manufactured in the UK and England and then shipped to Australia as a result of the gold rush and a lack of skills. And we also have in the US, the invention of platform frame as a result of mechanisation and sawmills and dimensional timber. But we also have, Isambard Kingham Brunel and the Renkioi Hospital, which was manufactured and shipped as a result of the Crimean War. So offsite manufacturing has been around for quite some time, and indeed timber has traditionally always been utilised, in part because of its strength to weight ratio. It's relatively light, which facilitates shipping. In the current context, these systems are still made in offsite environments such as cruck frames. Only now we use CNC machining, but we've, beam and post type construction has moved on, and now we've got things like what's happening with robotic calibration. We've got Mjøstranet in Norway, the tallest timber building at 18 stories, all timber construction using cross-laminated timber. And we're also using these digitised approaches, and there's companies even such as Norscot at the very top of Scotland and Wick using digital approaches for virtual reality and augmented reality. So it's been around for a long time, but of course it's evolved, and the engineered timber products and systems have evolved as well, and we'll cover much of that within the course. A key driver or key reasons behind why offsite, why timber? Well, we have a ballooning urban population, so we need to deliver that, given, for example, things like the housing shortage. So we need to do that, but we need to do it in a sustainable manner. So construction productivity is stagnated relative to other sectors, so we want to increase construction productivity. However, construction, half of the non-renewable resources that mankind consumes are used in construction. So if we accelerate productivity, we accelerate the climate crisis. So we have to think again very seriously about the materials that we're utilising. So if we use timber within the offsite approach, given the necessity for productivity improvement, then we can sequestrate carbon in the built environment and actually start to reverse the climate crisis through the delivery of the built environment and carbon sequestration. So essentially locking up carbon in the built environment is good in order to achieve the sustainable development goals. So that's why we want to think about off-site construction using natural renewable resources and timber. And in order to do this, we need to think in terms of sustainability, so the social, environmental and economic impacts. We need to think about value in terms of technical quality and customer satisfaction. We need to think about efficiency in terms of not just time, but also in terms of waste and flexibility. So how we can use standardized products for mass customization in order to meet customer needs. So we want to think holistically about what we're doing in order to create optimization. So in terms of value, as I say, quality assurance, improved thermal improved thermal and acoustic performance and R&D work. We want quality assurance, that factory environment, to reduce snagging on site. We want consistency of quality through the production processes and predictability of behaviour. So, for example, in a factory environment, you can control moisture content better, which is important with respect to timber. In terms of efficiency, we can run activities concurrently on site and in the factory to get just-in-time happening and improve outputs and productivity. We have a product family architecture of standardised component parts for mass customization. So when you bring standard bits together, then you're for mass customizable outputs. And we can use, as I say, what's happening in terms of the digitization space, computer design, computer manufacture to minimize waste and reduce and have waste reduction. So you can have 98% material yields within the factory environment. And sustainability, so social, we need to improve construction culture. Factory offers clean, safe places of work. In terms of the economy, we can, through a factory-based approach, we have local labour, local supply chains, creating economic viability. And of course, from an environmental perspective, we can think about efficiency, the qualified supply chain, so it's naturally renewable resource, and we can optimise and enhance overall performance. And we think about that through the whole value chain, from start of life to end of life. And ideally, we think of that in terms of a circular approach, which so the type of work that we do in the research centre does actually cover a lot of this, but we also do a lot of work with respect to structure. I think a key thing here is we're thinking about structure and how we can use calculated analytical approaches, how we can validate that through test, and then utilise that within products and systems that we collaborate on in terms of research, and such as, you know, hybrid service core products for social affordable housing. But when we're doing this, we have to think about structure, but we also have to think about, you know, not just the wider supply chain issues, all the other stuff involved, but even how that impacts upon the final building envelope in terms of, you know, thermal performance and acoustic performance. So we have to think about things like thermal bridging. So we have to take a holistic design approach. We do a lot of work, and this will be covered in the course of the project, within the course on mass timber products. So we're not just looking at panelised systems, volumetric systems, we're looking at the engineered timber products, including mass timber systems. So cross-laminated timber, nail laminated timber, dowel laminated timber, glue laminated timber. There's a range of mass timber products that we work on or have worked on and have continued to work on in order to have their place in the market. And again, some of this content. So I would say that our current research activity sits within sort of thematic areas of off-site productivity and capacity, human capital, skills and culture, mass timber construction and digitisation. It's not limited to these, but these seem to be the emphasis. But what it's primarily about is how we can encourage the use of contemporary timber technologies for the delivery of the built environment using a factory-based approach. There's a whole raft of information that sits under why we need to move down this road, both in terms of offsite and the utilisation of renewable natural capital timber. So you can look through all of this in your own time, and there's much more than has been shown here to get an understanding of why we need to go down this road. But just picking up on some of these, we can go back to you know, 50 years and more in terms of the Latham and Egan report and what it said at the time. So it was saying that the time had arrived, but obviously things have moved on considerably since then. But what we're seeing is, as much as things have moved on, it's very much with a similar emphasis. So that in 2013, this was released, which was the, you know, this construction 2025 strategy. So we're 5 years away from that in order to get you know, faster delivery, lower cost, lower emissions, and improvements in exports. So there's targets that have to be hit within this market, and a lot of what this points towards is an off-site manufactured approach. So there is a lot of current context in this. There's been now the relatively recent farmer review talking about the construction model. It needs to modernise or die. There's the industry strategy work laying the foundations, it's called. And then there's also building a safer future in terms of building regulations and fire safety. And then there was recently the presumption in favour of off-site manufacturing via the House of Lords. So there's a lot of work that's pointing towards off-site construction. There's a lot that's pointing towards the utilisation of timber, but at the same time, there's things that there's barriers to uptake, which we'll cover. But in particular, reference to that fire safety is a key one, given the combustible nature of timber. So that there's things that barriers over to have to be overcome in that respect, but certainly they can be, and there's evidence base internationally to demonstrate this. It's just about taking the right approach. So, as I mentioned before, productivity is key. Farmer highlighted this and the necessity for UK productivity and construction to change, hence why I need for off-site construction. And as I mentioned before, not just thinking of this in delivery on a linear basis, thinking of it in terms of a circular basis and a circular economy, and how we can maximise the value of our natural renewable resource and delivery of the built environment in line with circularity. And I would encourage you to look into these theories. So as I spoke to, there are barriers to uptake. A lot of these barriers are indeed just simple things like perception. This is the B Sky B building in London. This is a timber off-site solution. You might not think of it looking at it, but it was delivered using off-site and timber technologies. There's resistance to change. You know why you wouldn't build your car in the driveway, so why do you build a house in the field? So there's a necessity to change from this type of approach to much more efficient forms of delivery. However, when you move to a factory, you do need to have capital investment, so it's a different business model operation, and that has to be taken into cognizance when you think also about the procurement model. But what we're seeing here is a mass timber or a cross-laminated timber plant, so you can see the size and types of equipment that need to be invested in for these types of approaches to be utilised. As I say, it's a change in business model approach. There's a necessity to, to partner early in order to maximise the value of off-site construction. So if you come in and want to use off-site or timber off-site late in the day, you're not going to maximise the value proposition. There's a necessity for improved levels of guidance and information. I've given you, a recommended reading list. There is a reasonable amount, a decent amount of content out there, but sometimes it's just, explaining some of these terminologies: standardization, mass customization, optimization, product family architecture. What do these mean, and how do we need to understand them for future delivery? So, what we've kind of unpacked, I guess, so far is a range of different things. Now, what I want to just focus in on is if we think of construction and we think of current construction and a delivery model, then the drivers for construction delivery in terms of sustainability, improved levels of environmental credentials and the impact that can have, culture, the need for improved business models, the need for improvement in health and safety, the necessity for human capital, skills and collaboration and leadership within the sector, improved levels of productivity, lean thinking, and construction performance, digitization as we move towards the Internet of Things, or in the Internet of Things, indeed, the fourth industrialized revolution, and regulatory drivers as we move forward as well. We're now, Eurocode, as much as Brexit has happened, we have taken on Eurocode and there's been harmonisation of that in terms of structure, but there's a wider regulatory requirements as well as we move towards things such as net zero carbon. So if you think of these different drivers and how these drivers can converge on a given context, whether that be a national context in terms of the UK or Scotland, or indeed the site context and what needs to be delivered, whether it's a one-off bespoke system or whether it's something that can be rolled out with a degree of repetition, such as student accommodation. If you look at the convergence of these drivers, they point towards off-site construction and off-site approaches. It's just what type of off-site approach. Is it panelised, sub-assembly, volumetric or hybrid, and to what level of enhancement? But fundamentally, we shouldn't be delivering loose materials to site and subscribing to lowest cost, lowest quality forms of delivery. and not that it would generate waste and have a huge impact on the environment in terms of the utilisation of non-renewable resources. So please think about this in terms of what you're looking to do and specify in the future. And I would suggest very strongly that it has to move down an off-site, an industrialised timber technology approach. So just to kind of like give you a sense of this and sort of walk you through it as a wee bit of a kind of learning journey, which we've done with students in the past, and we collaborated on this when we had Harvard Graduate School of Design students and our Built Environment Exchange students. They went on a learning journey in Scotland to understand these drivers and why we should be using off-site and timber-based solutions. So in terms of human capital, we visited CCG in Glasgow, which was established in 2010 with a £12 million investment, and has year on year increased its turnover, its number of employees, and it produces panelised timber systems. So CCG are actually part of a wider collaboration in Scotland of Offsite Hub. Or it was Offsite Hub at the time, which has now become Offsite Solutions Scotland. And there's underpinning information with this in terms of how we worked with CCG to develop skills content for upskilling of apprenticeships, but also to create wider outreach into for example, architectural practices. And we created a methodology for collaboration between different partners in the formation of Offsite Solutions Scotland. And there's publications that are available with respect to that. So you can see Offsite Solutions Scotland, the spread of offsite operators, or some of the more advanced offsite operators in Scotland, who all utilise timber offsite based solutions. And we undertake work on their behalf, funded by the likes of Scottish Enterprise, Construction Scotland Innovation Centre, with intervention from Scottish Forestry. The work undertaken by CCG is panelised solutions, and we've worked with them with respect to their fully enhanced panelised system. And when you move to fully enhanced systems and you think about the regulatory changes, you have to think about the connections and the transfer of shear indeed through these connections. So we'll cover some of that over the course of the programme. So we've worked with them on this in order to evolve solutions, and those solutions have been utilised in live projects in terms of just standard housing delivery. But of course, there's 50,000 houses required in the term of this Parliament, the Scottish Government. So housing is a key deliverable. In terms of regulations, we've worked with, again, CCG in this case, and I mentioned this before, the tallest timber building in Scotland, which is Yoker, and it's a CLT building. It's 8 stories. And we use mass timber product for the delivery of that in terms of cross-laminated timber. So we've unpacked this information, and this publication is available as well, which covers off a range of the different mass timber systems. And again, we will cover that during the course of the lecture series. And what we'll also do is look at some of the case studies that we've worked on, such as Multiply and our research and intervention, with a particular emphasis on quality assurance and how Multiply could be delivered. And Multiply was manufactured in Scotland at the Construction Scotland Innovation Centre. It used imported tulip wood from the east coast of America in partnership with the American Hardwood Export Council. And our role was largely around the quality assurance, as I said. So undertaking test work to demonstrate the structural performance of the different constituent parts in order to ensure it was safe for use. And this is Multiply at the V&A in London. It was a public exhibition. It resided outside there for a while, and then it got moved. It got assembled, but then it eventually got disassembled and actually moved and taken to the likes of Milan to showcase it there. And it was all about encouraging people to think differently about offsite and timber-based solutions. Culture. Well, on the learning journey, actually, we went to Falkland. So Falkland's an interesting estate. It has renewable resource there in terms of timber material and Scots pine and larch, and there's a small wood there where they're looking to build off-grid recreational huts. So when we went there, it was all about, what is a recreational hut? It's a simple building used intermittently for recreational purposes. It has a small floor area in order to get planning consent or relaxed planning consent, and it has to be constructed using low impact materials, again, such as timber, and built in such a way that it's removable with little or no trace. So again, aligned with the theories of circularity. So what we undertook for that was a design for manufacturing assembly exercise and indeed disassembly, and looked at how it could be fabricated using panelized systems in order to allow you know low skilled labour to erect it. So we used digital approaches to do that, and we're able to produce panel drawings with cutting lists and material specification to facilitate use. And importantly, thinking about what you can use the digital model for is to get the weight of each of the individual panels for the to allow for manual handling to take place. And you can see that's the nature of the hut there. We also looked at sustainability in the learning journey. We visited BSW Timber. BSW, the largest sawmill in the UK, they have an annual turnover of 320 million, employing over 1,000 people, and they produce 3,462 meters cubed of timber per week. So quite a very sizable operation. So we went there, but I think the key there, why we went to BSW to explore sustainability, is because as an operation, they use 100% of the log that they receive. So they have a zero waste strategy. So they have a zero waste strategy, and then they're processing timber, and then that timber can go on and be turned into a structural component. And of course, timber sucks carbon in from the atmosphere. So if we put it into a structural system, then you lock that carbon in for a longer period of time. And a lot of the work that we are doing in around this in the bioeconomy is to try and enhance that type of approach. So enhance the level of timber products that are used, UK timber products that are used within construction, to move it upwards from the current 20%. And as I say, that theory aligns with the circular economy. So we're maximizing the value and ensuring that we have waste reduction throughout the whole process in order that we can sequestrate carbon in the built environment. A lot of the work that's done at E&U with respect to this is to think about timber grading properties. So you'll cover this and understand better what is meant by structural grades of timber, and indeed why in Scotland a lot of our timber is stiffness limited. So often it's graded at C16 by as a result of how the yields work. So you can get higher grades, but if you go for the higher grades, then you would tend to create more waste, in the sense that it wouldn't be waste because it would be used for something, but not necessarily for the higher value activities. So some of the work that we've done, or colleagues have done in the Centre for Wood Science and Technology, is to look at other grades or how you can better utilise homegrown timber, and have determined a grade in terms of C16 plus, which better maximises the performance. So you can see that the bending stiffness is equivalent to C16, but we have a higher strength and a higher density. So of course that helps you structurally in terms of strength, but density helps you of course as well in terms of connections, which we'll come to later. So I spoke about digitisation is very key, and actually as part of to explore digitisation on this learning journey in Scotland, we visited Carbon Dynamic, a much smaller outfit, but they have invested a great deal in terms of how to use digitisation within their product delivery. So in this respect, the Dyson Institute of Technology, which we've seen a few times now in this digital image, was fully digitised to facilitate things how you could structurally analyze it, because they were looking at quite ambitious cantilevers. So they had to model that, but we also had to structurally test it, using a series of strain gauges, and dial gauges rather, and applying strain to the system in order to measure deflection under high loading conditions. So that was work that was done. Indeed, Rory Doak at the time, when he was employed here via the Built Environment Exchange, undertook that work, and they built a mock-up of the system and tested it and measured the deflection and correlated it with the structural model. So the structural model would be verified, and then this would ultimately validate that approach. And of course, that allowed the system to then be delivered and delivered successfully. Finally, just to encapsulate all of this and consider productivity a key driver, but thinking a wee bit differently about productivity, because often, as I say, if we just think about productivity in terms of outputs relative to inputs, then actually what it can do is accelerate climate change. So we want to think about productivity, and in Scotland we have a particular problem, indeed worldwide we have a particular problem around vacant and derelict land sites. So thinking about productivity with respect to productive use of land and how land could be used more productively. So we actually undertook what we call design thinking exercise with students from the Built Environment Exchange students and Harvard students, and as a result of the learning journey and what they'd unpacked through this approach, and set them a challenge to deliver and take on a very vacant and derelict land site in the middle of Edinburgh, which is now possibly being converted, and to engage the local community to determine solutions. So the solutions they've derived are actually quite different from the solutions that are probably now being implemented, which is an extension of a hotel. But what the community were saying was actually we want community space, and then from the understanding of off-site and industrialised timber systems, solutions were derived which were compatible with the site. So it just gives you an emphasis of the type of work that was undertaken. So just to unpack that, what we want to think about is sustainability. Industrialised timber construction can provide a clean tech solution for the delivery of the built environment. Culture, the built environment should be created in a manner which delivers sustainable communities and a wider cultural impact. Digitisation, a digital thread can be realised from forest floor to built asset with a feedback loop for continuous improvement. Regulation should not drive innovation. Innovation should challenge regulation, and we're definitely seeing that. And productivity is not simply about increasing output relative to input. And then, of course, human capital is engaging with the consumer, can pull innovation through the process. So that's why if we do that, then we can evolve the regulations as a result of what innovation is needed for the delivery of the built environment. So that was some of the conclusions that came from the learning journey. And if you want to find out more about this and learn more about the different products and systems, then we did actually do a public exhibition, which is no longer at Architecture and Design Scotland at the Lighthouse, because that closed at the beginning of 2020. But the content is online at the link, and you can view much of the content, and it's also currently displayed at the Construction Scotland Innovation Centre. So a lot of really good content there which you could look to explore to understand the varying theories behind this. So hopefully we've built the case. Often something I try and do when you guys will all be thinking about your research projects. But before you sort of determine what you're doing, it's an understanding the full context of why you're doing it, and correspondingly justifying your approach. So hopefully you've got from this at least a sense of the justification of why we need to use industrialised timber technologies and off-site construction systems. And then what we'll do through the course of the project is we'll meet those learning outcomes, and you'll receive lectures on a range of different information, and that will go very we'll just canter through some of that to give you a sense of what you'll be doing and thinking about. So as a result of this, we will, for example, look at material properties. You will get an understanding of, to an extent, the molecular structure of timber and how the growth of timber and the introduction of defects influences its structural properties. What the impact is in terms of moisture content on timber and how that affects its design. So we have to think about holistic design and informed detailing and quality assured building practices within highly energy efficient building fabrics. But to do so, we fundamentally have to understand the materials. So those failure diagrams, they come from Bodig and Jane, which I've encouraged you to look at, so you can get a full understanding of the resource and what impacts upon the resource, and indeed why we might want to re-engineer it. You'll get a full understanding of, as I say, strength classes and what's why these are, or how these are contained in EN 3338 and how they were utilised in structural design calculations. And within that, we understand that the constituent parts, and often the weakest link in a timber structure is the connections. So, and there's a whole range of connections out there. So we will definitely touch upon a range of connections. You'll get an understanding of what makes up the connection. So in terms of varying dowel type fasteners, it can be screws, it can be nails, it can be bolts, it can be timber dowels, it can be plate type connections, both in terms of tooth nail plates or connector plates. There's other interesting timber connection systems, split rings, shear plates, tooth plates that are used for varying different types of applications. So you'll get an understanding of these. And of course, there's glued joints as well. So the engineered timber products are made up of glued joints, or often made using glue. Not all the time, because there's nail laminated timber, dowel laminated timber, etc. But often glue is used for things such as eye joists, which often combines two different types of engineered timber products in terms of oriented strand board um, for the web, and then an engineered timber product such as laminated veneer lumber for the flanges, and they're glued together. With respect to connections, we'll be looking at Eurocode design of dowel type fasteners within this. You'll get, as I say, there's a whole range of connections, and then how you design for them, and how you, when you design for them, thinking about the failure modes relative to the connection type, but also the dowel type used, and indeed the strength classification of the timber, because that will essentially influence its density, and density influences, for example, the embedment strength of the timber product. So these will become clearer, and indeed what you'll get is an insight into the calculation approaches for this as well. So these are all mathematical calculations, of course, and you'll understand the different factors to plug into these so you can understand the failure mode, which can then also lead you into how you can optimize that connection. Within these, as I say, there's things like embedment, which is affected by density, and there's empirical equations which allow you to determine that for the varying timber products and systems. So you'll get encouraged to, of course, look at this. You'll look at the different failure modes and get an understanding of how each of the calculations reflect these failure modes. So here what we're seeing is embedment in the T1 timber, which will be as a result of its reduced thickness and possibly also its reduced density. So the different failure modes is what you'll run through, even when you're getting embedment in all three members, etc. So double shear failure modes and associated equations. So you'll get a handle for these equations, and you'll be able to utilise them within the likes of your coursework. That covers strength. We've also got to consider stiffness, and the stiffness. So obviously a glued joint is highly stiff relative to a nailed joint, particularly if it's a single nailed joint. So there's a range of different stiffnesses of different connections that ultimately affect the serviceability criteria of your structure. And you can determine the load slip behavior again through uh, empirical equations. So a series of tests have obviously been undertaken, equations have been derived which are reflective of performance, and correspondingly you can plug in the information with regards to getting the information. So you either determine it via calculation, or indeed you could undertake the necessary test work to also get the values needed, particularly if it's a non-standard situation. So just explore upon that, and I've touched upon the likes of closed panel systems. So as you move to do higher levels of enhancement in the factory environment, that therefore has an impact upon the installation process. So what you're seeing here, for example, is a fully enhanced panel. This is Stuart Milne Timber Systems Sigma 4. I think the interesting thing to look at is the detail at the bottom and the relative connection details in there. Because when you think about racking performance or structural stability, again, this is something we'll cover in more detail later in the course. The application of those forces have to be transferred through the system and correspondingly into the foundations of the building. So you'll be able to calculate the racking resistance, and the racking resistance is based upon the balance of moments. So you can look at these types of equations and check that they work. But essentially, the more holding down that you have at the foundation, more holding down straps that you specify, the more fixings that you have that will provide shear along the base. And the more shear transfer that you have as a result of holding down, the enhanced level of performance that you'll get from the panel itself. But what you have to think about in terms of that shear transfer is the connectivity and the varying slip planes that are within there. So both in terms of structure and shear transfer, but also in terms of slippage of the system, given the necessity to think of serviceability. So there's a whole range of ways that you can actually do this. And when you're doing it, you're thinking about how you can reduce cold bridging, but at the same time get structural performance. And as I say, what you can do is if this is relatively non-standard, then you can undertake a series of test work. And I often say you look at things in isolation to consider them in combination in order that you can understand the full effects. And then you correlate that with the analytical approach, and correspondingly the test approach can validate the analytical approach such that you can make a robust specification. So we've done that, and we, as you'll probably find out as well, is we have an established relationship with Trimble. They've got software called Tekla TEDS, and we've embedded our research finding into that software. And as a result of the university's engagement with Trimble, you have access to these softwares and will have the opportunity to use them. But I think what's important as you are using them is to understand the underpinning approach. Because when you do design work, you get a design calculation to work, but what you also have to take cognizance of is that design detail is part of a much larger structural system. So, and there's a range of structural timber systems. So we've touched upon residential, but if you go to the Scottish Parliament, the roof structure of that is as an engineered truss system. Using timber in combination with steel ties. You've got the likes of the Bullet Building in Seattle, so it's LEED excellent, so it's one of the most sustainable buildings in the US, and of course it's delivered using mass timber products, including neo-laminated timber, because of the carbon sequestration details. You've got the England B Sky B building, as I say. You've got buildings at height as well around the globe that are going up as a result of things like mass timber and cross-laminated timber. But you also have interesting structures like grid shell structures. Buddha Happold and now retired Richard Harris did a lot of research work on grid shell structures, really interesting systems that are all based upon the connection detailing. We have our own grid shell structure at Craig Lelkart, which we'd be encouraged to try and visit and think about the structural performance of that. And recently, there's a multi-award winning Macallan distillery. And let's combine two of my favourite things, which are whisky and timber engineering. And there's a Macallan distillery in the north of Scotland using a grid shell timber structure. And again, actually, interestingly, the constituent parts for this were the roof system are manufactured off-site. As I say, I mentioned the Seattle building, and you can see here how it's fabricated using Neolam, and it's got steel in there to provide additional stability. So often, things need to be hybrid, but it's thinking about what to use and when to use it appropriately. And you can see the B-Sky building now exposed, and the range of timber products and systems that were used within that, including large off-site fabricated closed panel systems for the external walls. Other really interesting things to look at is like open sourced approaches to timber engineering. There's like a WikiHouse. And preceding that, there's pioneering research as such done by Lauren Sass at MIT around this, and this is using digital approaches for mass customization. So given user input. So WikiHouse it uses a digital platform which you can design, and then you can fabricate out using CNC machining the shapes essentially, and then fit them together using a mallet hammer. So to create the connections between the holes cut in the plywood. So there's really interesting approach to that, and the Construction Scotland Innovation Centre have trialled this approach using some of their equipment. So encourage you to look at that. Do a lot of work on tall timber buildings, a lot of theoretical work, a lot of work done in 2012 and moving forward from that. Essentially looking at how high you can go with timber built systems. Tall wood. So this one is very much exploratory, and what it does is it throws up different challenges in terms of how you can achieve, up to 30 stories using timber-based products, and what that means, and indeed whether those products can currently be manufactured, and if not, what needs to be done such that they can. We've seen Mjorstranet, but it is currently the tallest timber building. So as much as the theory was looking towards 30, we've hit 18, and these will go higher ultimately because of the techniques that are being deployed. So it's an old timber built system to the extent that it's even timber cladded. So as much as there's things happening in the UK as a result of Grenfell to create restrictions in height of combustible materials, which is then going to impact upon the timber market, we're seeing a restriction at about 18 metres at the moment, which takes you to about 4 or 6 stories, and there's been talk of that reducing down to 11 metres, so capping you between 2 and 4 stories. In Europe they're going up to in Norway they're going up to 18 stories, and let's not forget that Grenfell had nothing to do with timber. So um, it can evidently be done, and you can do it with what are regarded as combustible materials in terms of timber, because it can be safely designed, detailed, and implemented. However, a holistic design approach needs to be taken, and later on we'll explore some of the issues around fire, indeed, and durability. But as they say, it can be done, and fundamentally we need to challenge what's happening at the moment in the UK, and indeed it is being challenged. You can combine timber with other materials. Um, in the bullet building I showed a brace frame, but timber flitch beams, timber and steel. So you're trying to enhance the structural performance of the timber via the introduction of a steel component, but still, have a largely timber system. So you're sequestrating carbon, or you have timber concrete where you're using a thin screed concrete in the compression zone and using timber in the tension zone, because obviously timber performs better in tension than concrete does. But then what concrete can give you is thermal mass of your flooring system. So the building heats up, the concrete can store the heat, and then when the outside temperature or the sun goes away, then it would release the heat back into the building. So there's advantages and disadvantages to think about in terms of the utilisation of material. But fundamentally you can get to holistic solutions, and that's what they did at the University of Massachusetts, for example, in Armhurst. Largely timber building, but they used timber concrete composites within the delivery of the flooring system. Mechanisation, we'll look at roofing systems later on in the course. Mechanisation, automation is the work that's been done for delivery of roofing systems to improve productivity and reduce working at height. And that was some of my original PhD research. But then there's really neat things that have been trialled by Vetocato, where you land the roof in situ, and then like an accordion you pull it out using a motorised system. Now that all has challenges in terms of the structural detail and all of it, and some of the work that we've undertaken is to address those challenges. And then I mentioned, or you've seen some stuff at Zurich, really interesting to look at in terms of man working with machine, in terms of what we call sort of personalization. So it's really interesting to look at some of that. And what's really interesting is how what's been undertaken, it starts to challenge what can currently be done through structural engineering, because you're able to create forms and structures which wouldn't necessarily normally have been achievable, because how man and machine are working together. So really interesting to look at that. So just to close off, as I know it's a bit of a canter through, but what I wanted to really give you was, an overview of the course, the justification for why we're doing it. What's the context we're working in, what's the learning journey such that we'll go through during the course of this lecture series, so such that you can develop a fundamental understanding of timber engineering, because timber engineering is very much on the upward trajectory, given the necessity to deliver the built environment more sustainably. That's absolutely key. So please do take cognizance of that and why this subject matter is very important. But fundamentally, for sustainable design, we need to have holistic decision making to ensure longevity and robustness. We need it for fully engineered for robustness, so that solutions last a long time and sequestrate carbon in. And we need to give due consideration with that in those terms, with regards to not just the end built asset, but additionally the capabilities of the factory, the logistical operations, the design for manufacturing assembly, and indeed disassembly, in order that it can be reconstituted and reutilised in order to ensure that we maximise value consistently. And that therefore aligns with the theory of and the paradigm of the circular economy and circularity, which is fundamentally necessary given the need for us to move towards a more five capitals model approach in terms of built environment delivery. And then what construction needs to do and is doing is evolving towards a more off-site forms of delivery as a result of the convergence of the drivers, which fundamentally means biogenic off-site manufacturing, utilising natural renewable capital, timber, which therefore necessitates the need for timber engineering. So with that, I'll thank you very much, and hopefully you enjoyed this first episode as such, or first lecture of the lecture series, and we very much look forward to seeing you in the following weeks. So thank you.